Welcome back, Focus Learners. Today, we're looking at a historical biography that is absolutely going to blow your mind. We are tracing a direct line from an 11th century tale of desperate survival right to the very smart find sitting in your pocket right now.
I mean, think about it. How exactly did a fake bout of madness give us the modern camera? It sounds like the plot of a Hollywood movie, right? But it's entirely real, and it brilliantly illustrates how human drama and scientific breakthroughs are just deeply intertwined. We're going to see how a guy trying to escape a terrible day job accidentally enlightened the whole world.
Okay, let's dive into this. Section 1. Escape to 11th century Egypt.
So picture this. We're in the Islamic Golden Age, a time of massive cultural and scientific flourishing. The famous House of Wisdom was established in Baghdad around 786 AD, and it was this incredible hub for research and translation. Into this vibrant world, our main guy, Hassan ibn al-Haytham, is born in Basra in 965 AD. He was a true polymath, studying everything from math and astronomy to medicine and engineering. But by 1006 AD, things took a turn and he had to flee to Egypt. Why? Well, he was a famous architect back in Basra, and the local prince ordered him to personally build a royal palace. Al-Haytham basically said, "No way, I'm a scientist, building is the work of laborers." As you might guess, the prince didn't take that too well. He accused him of hidden atheism, which back then was a literal death sentence. So al-Haytham ran for his life.
Now, al-Haytham's mindset was completely radical for his time. He famously wrote, "Whoever asks for certainty doesn't look in the books of predecessors, but questions their concepts and follows proofs and evidence." This perfectly sets up his whole vibe. He was rebellious, deeply empirical, and he didn't just blindly accept what ancient authorities said. He demanded to test things for himself.
Which brings us to Section 2, the impossible Nile Dam. That rebellious testing mindset brought him straight into the court of al-Hakim, the ruler of Egypt, right during a severe drought. Al-Haytham confidently waltzes in and claims that if he just had access to the Nile, he could regulate its flooding and save the entire country. Al-Hakim was absolutely thrilled. He treated al-Haytham like royalty and handed him a massive deposit of 3,000 dinars to head down to Aswan and build this dam. Now, 3,000 dinars was an unbelievable sum of money, and he got it despite heavy skepticism from the royal court, especially from al-Hakim's sister, who rightly pointed out that not even the ancient pharaonic engineers had managed to tame the mighty Nile.
But when al-Haytham actually got to the site in Aswan and stood there looking at the rushing, chaotic floodwaters, absolute despair set in. He looked at his designs, he looked at the basic tools his workmen had in their hands, and a brutal truth hit him. To withstand that kind of intense water pressure, he needed construction materials that literally had not been invented yet. He realized it's not time yet. It just wasn't technologically possible to build a dam on the Nile in the 11th century. So he had to trudge back to Cairo and admit total failure to a ruler who was notorious for being incredibly dangerous.
Shockingly, though, al-Hakim didn't execute him. Instead, he handed down a totally brutal demotion. He took back the 3,000 dinars and slashed al-Haytham's salary to just 4 dinars a month. Worse, he assigned him to be a lowly, mundane accountant in the government's salary department. For a brilliant, creative polymath, this repetitive corporate slavery felt like a fate worse than death.
And that leads us to Section 3, Madness and the Dark Room.
Trapped as an accountant, he knew he was going to genuinely lose his mind if he stayed at that desk. So that desperation sparked an incredibly risky, wild plan. He figured if he was going to go mad anyway, why not just fake it to get fired? He started crying, laughing to himself, chasing his own shadow, the whole shebang. And you know what? It worked. He was relieved of his accounting duties. But al-Hakim didn't just let him walk free. He placed al-Haytham under strict house arrest for 3 full years, with guards watching his every single move. To check if he was truly insane, those guards drilled a single tiny peephole right in his door. And guys, here is the profound historical irony. That confinement and that specific tiny hole would completely change human history.
Now, what's really interesting about this next part is how he used that time. Section 4, Rewriting the Laws of Light. Sitting alone in the dark entirely shifted our understanding of reality. For centuries, the absolute greatest minds, people like Plato and Euclid, believed in the emission theory. This was the idea that our eyes actively shoot out beams of light to illuminate the world, almost like laser pointers. But al-Haytham realized this accepted ancient theory was just absurd. He asked a brilliant, simple question. If our eyes shoot light, why on earth can't we see in the pitch black dark? Instead, he proposed the reflection theory. arguing that light travels from a source in straight lines, reflects off objects, and then enters our eyes. And he proved this all because of that tiny peephole the guards drilled. When sunlight bounced off people walking outside his house, the light rays traveled in straight lines right through that tiny hole and projected an image onto the opposite wall of his dark room. Because the hole was narrow, the light rays from different points of the object didn't overlap, which created a sharp, distinct image. And because light travels straight, the rays from the top of the person outside went to the bottom of the wall inside, and vice versa. He essentially saw a sharp, upside-down movie of the outside world playing on his wall. He had just discovered the camera obscura, which literally translates to the dark room.
But he didn't just stop at physics. He applied this directly to human biology. He realized the human eye works exactly like his dark room. He identified and named the very parts of the eye that we still use in medicine today. You've got the cornea, which is the transparent outer surface where light enters, the iris, the colored middle section, the pupil, which acts exactly like the peephole in his door, widening and narrowing to control the light, and the retina, the back wall of the room where the upside-down image is projected before our brain flips it right side up.
Moving right along to Section 5, Birth of the Scientific Method.
Al-Haytham's work with the camera obscura was revolutionary, sure, but how he got there was arguably his greatest gift to humanity. He didn't just study light, he revolutionized how we study absolutely everything. To really appreciate this, we have to look at what ancient science was like. Heavyweights like Aristotle actually hated physical experiments. They believed that because physical conditions constantly change, you should just rely entirely on pure logic and rational thought. Aristotle relied so heavily on his brain over his eyes that he famously claimed men have more teeth than women. The guy was married twice, but apparently never bothered to just ask his wives to open their mouths so he could count.
Well, al-Haytham refused to be that lazy. When he was finally freed after al-Hakim's death, he published his masterwork, the Book of Optics, in 1021 AD. In it, he laid out this exact step-by-step toolkit for finding the truth. First, you notice a pattern. Second, you doubt past assumptions. Third, you form a hypothesis. Fourth, you actually run the physical experiment. And finally, you record the result. He demanded that we test everything. This right here is the birth of the empirical scientific method that we still use today.
Within this framework, he formalized some key logical concepts. Take induction, for example. This is when you deduce a general, universal law from specific partial observations. By experimenting with his camera, al-Haytham saw that light always entered in straight lines, regardless of the light source. Now, even though he obviously couldn't test every single beam of light in the universe, he correctly used induction to declare the universal law that all light travels in straight lines.
And on the flip side, we have deduction. This is applying a proven general law to explain a specific special case. Through his camera experiments, al-Haytham proved the general law of refraction, which is that light bends when moving between materials of different densities, like from air into water. So when you look at a stick resting in a glass of water and it looks broken or bent, you can use deduction to explain that specific optical illusion using the established general law of refraction.
Let's move on and see how this builds into our final section. Section 6, Legacy of the Modern Camera.
There is an incredible leap in history here. Al-Haytham writes his book in 1021 and passes away in 1040, having successfully taught the world how light truly behaves. But it wasn't until 1826, literally about 800 years later, that a man named Nicephore Niepce in France managed to do something truly magical. He took al-Haytham's exact darkroom principles, combined them with light-sensitive chemical materials, and finally managed to freeze time. He captured the very first permanent photograph, letting the light itself draw the image instead of relying on a painter's brush.
Which brings us to the absolutely crucial takeaway of this explainer. Every single photograph taken today relies on a man who was trapped in the dark over 1,000 years ago. Whether it's the quick selfie you just took on your smartphone, a massive blockbuster movie shot on a digital sensor, or those breathtaking images beamed back to us from space telescopes. All of it, the whole shebang, functions entirely on the physical laws of light and optics discovered by Hassan ibn al-Haytham while he was faking insanity under house arrest. It really makes you wonder, doesn't it? What other modern technological marvels, things we use absolutely every single day, might have been born from moments of total isolating desperation in our ancient past? Keep that in mind the next time you snap a photo. Thank you so much for joining me on this explainer. Keep asking questions, and I'll catch you next time.